All right, so let's go to percentages. All right, so it's not just like pure percentages. I don't want you to give you the perception that it's the only type of problems that you'll see. But here is one that's a lot like what we were working on before. It is a story problem. What I want to, when you read this, I want you to think about whether the final answer is bigger or smaller than the given number. Maybe that
Um,
will help. So go ahead and look through that.
well, all numbers here are bigger than the than
This is
the
the given number.
percentage. Yeah, the percentage is smaller.
So not all the numbers are bigger and not all are smaller. And sometimes that's helpful.
So smaller?
Okay, so it's saying here that, and sometimes you want to just use like letters like um, M. M is 96% of B.
And
So is B bigger or smaller than M? Which
is
is
M
bigger, M or,
2010?
I'm sorry?
Is M 2010?
No, M is Milwaukee.
Oh,
So th this
um,
whole, this is a comparison between two groups. Group one is 96% of group two. Group one is Milwaukee. Group two is Baltimore. So what I'm asking you is which is bigger, Milwaukee or Baltimore, based on this?
Milwaukee.
Okay, but it says Milwaukee is 96% of Baltimore. That means it's it's if it were bigger, it would say like 105% of.
Oh, so it's smaller. Oh,
Yes.
oh,
Okay, so but which population is it asking about? Is it asking about Milwaukee, which is given, so it wouldn't be asking about
oh,
that. What is it
it's
asking about?
Baltimore's
Okay.
part.
And the dividing line is right there.
Hmm.
So what is the correct answer?
Uh, A.
Is A, because Baltimore is bigger than Milwaukee, so it has to be the bigger number.
Mhm. All right.
All right, so here is another question. It's kind of like this one where you can sort of remove some answers based on the information in the problem here. Let's take a look here. Book was on sale for 40% off its original price. If the sale price of the book was $18, what was the original price of the book? So is the price of the book bigger or smaller than 18, the given quantity?
So 18 is the sale price.
Yes, yes, exactly.
Okay, so it wouldn't be smaller.
That's right. It would be
So
larger.
it wouldn't be 10. It wouldn't be A and B
Okay, that's good.
cross amount. So it would be I
There's a
would
couple ways to do
say
it. Yeah, give it your best shot here.
D.
Okay. So there's a couple ways to look at it. The discount is 40% of the original. The sale price is 60% of the original. Okay. Do you see the difference? Like we actually don't care what the discount is. You care about what you end up paying. So 18 is equals 60% 0.6 of the original price. I'll call the original price X. How do you solve for X in this equation?
Mm, I don't know.
What's the math operation here?
That's the multiply symbol.
Okay, how do you undo multiplication?
Division.
All right, go grab your calculator and tell me if that is the same as your answer or different.
6, 3. X equals 3.
Is that the same as your answer or do you want to change it?
I'm gonna say I'm gonna change my answer to C.
Okay, it is C, but kept saying 3. Did you divide by 0.6? 0.6.
No, I just divided by 6. Crap. 1 second. It's 30.
Okay, big difference. It's important. Now, why is 60% 0.6?
Because you moved the decimal
How many places?
once or twice. Once or
So you're
once.
dividing by 100, which is 2 decimal places.
Oh, so yeah, it was 10. I mean, it was 2.
Okay, so the final answer is C. Do a couple more here. We're gonna get into another topic also, but this is another one that's kind of like what we've been doing. One of the things you should think about again while you're reading the problem, while I'm reading the problem is the given quantity bigger or smaller than the answer? So it says a customer paid $50 for a jacket after 6% sales tax was added. So this price includes the sales tax. What was the price of the jacket before the sales tax was added?
Well,
So
we
is
can
the
just
answer bigger or sorry?
so we can immediately cross out the ones that are s- smaller. Wait a minute.
These are all smaller.
Yeah, I realized that.
Yeah, so unfortunately, this one doesn't help you with that technique.
Oh wait, $53 is the original price.
Well, let's read it again. A customer paid $53 for a jacket after a 6% sales tax.
Oh, so this
So
is
the
after it
original
was 6% off.
plus the tax equals the 53.
So we're still looking for the original.
We're looking for the original.
Okay, then I think it was A.
Okay, you're just guessing. So you can't guess. That's not a good strategy here. Okay, so here's the
I know.
formula.
No, I'm not guessing. I'm just
Okay, well then tell
thinking.
me how you got this answer then without just saying, well, that one looks like one that could be right. We want to use some math here, some numbers.
Well, I was thinking like if if it's like 6% off, it was like it was shoddy math. I just like added
All right,
6.
so the new price or the like the given price, what they pay is
Mhm.
also the original price times 1 plus the percentage. What is the percentage in this problem?
It's 6.
And what is 6% as a decimal?
0.6.
Okay, we just did this in a previous problem. You
Oh,
divide by 100, which means to move the decimal 2 places.
oh, right. Sorry. So you
It is not zero point 0.6.
60, right?
Okay, where is the decimal relative to this number?
Um,
Is it left or right?
oh, it's right
Okay, now moving it left. How many times do we move it left?
once. Oh, twice.
Okay, 0 fills in any empty space. So I'll ask the same question again. What is 6% as a decimal?
0.6.
Here's what you just said. Is that
Oh,
what you meant?
yeah.
Okay, but didn't we just move the decimal left so that it's here?
6 point.
Okay. So let
I'm
me try to.
sorry.
It's okay. I'm going to try to clarify this. This is a common thing the student struggles with. Okay, 40%, 40%, 40 point. You move the decimal twice. Okay, it goes right there. And so the answer is 0.40 or 0.4. You can leave off the zero. 4% is 4, but you move the decimal left twice. You put a zero where there's an empty space, and it becomes 0.04. Do you see the difference?
Yeah.
Okay, it's an important one. This is going to come up over and over again in your classes. Maybe not geometry, but other classes. So 1 plus zero point 0.06 or 1.06. Let's call your original price x. How do you solve for x in this equation?
You divide by 1.06.
Okay, so I'd like you to do that.
Okay. With 0.02.
No. Are you putting in top
I put
number divided by the bottom number?
I put in uh wrong place. It's 50.
Okay. Now, as an aside, if this were a non-calculator question, the
Mm-hmm.
only number that's even reasonable to do this without a calculator with is letter B.
Yeah.
All right. Okay, let's talk a little bit about polynomials. We're going to switch topics here. Do you remember the acronym FOIL as it relates to something like this?
I think I remember. I don't remember the acronym, but I do remember
Okay,
that.
do you remember how to multiply this? Sometimes called the rainbow method.
Mm-hmm.
Okay, could you attempt to multiply this for us, please?
Okay. Oh, so x is one, right? It's like one x.
So what I think you're asking is what is x times x, and that is x squared.
No, because I was thinking of in my some classes that x like one x can just be written down as x because there's only like one x. So you don't really have to clarify this one x. It can just say x.
Yeah, you can put a one in front of the x. Yes, yes, that's what you're asking. Yes, that is correct.
Wait, I have to add them. I forget or multiply.
So it would have been better to say, "Hey, Matthew, I have no idea how to do this." You gave me the impression you have some
No,
knowledge
I,
of
I
this.
remember. I remember. I do
You
remember.
have
I was like, I did it all the way back in my like beginning of like algebra one. That was like
Okay, so let's
almost
start
like
with
10
this.
years ago.
What is x times x?
X times x is x squared. Yeah.
Okay, and then
Mhm.
to your point, 1x times negative 5. 1x times negative 5. What does that become?
-5. So hold on.
So the 1 and the negative 5 can multiply, so minus 5, and then the x comes with it.
Uh,
Okay, now let's do plus 2 or 2 times x. What does that become?
that's 2x.
2x, good. And then 2 times negative 5 becomes,
Uh, -3.
you're multiplying.
Oh,
2 times negative 5.
-10.
Okay. Now, these you're adding together, the outer and the inner.
Outer inner,
Yeah, the O and the I. What is minus 5x plus 2x?
that would be -3x.
Good. All right, so this is your final answer. So let's do another problem together here. X minus 3 times x plus 6. All right, which one should go a bit faster? What is x times x?
That's x squared.
Okay, and then x times positive 6.
That would just be 6x.
Okay, and then the inner, remember you're taking the whole operator with it, so it's really -3.
-3x.
Okay, and then times the last.
That would be -18.
Okay. Combine the two middle terms here, please.
That would be 3x.
Okay, very good. All right, so here is one to try on your own, please. This is a legitimate SAT, ACT question you might see, so give that a try.
Okay, so it would be y squared plus y minus 20.
Okay, so which is the correct answer?
Oh, it's B. No, 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 not B. A. Sorry.
Yeah, and this you just revealed one of the things that's frustrating about standardized tests is you actually did the right work, you said the right answer, and then like let's just say conceivably you could actually mark down B and think you've done it gotten the right answer and is actually A, even though you did everything else right. So it's kind of a game. These standardized tests. So let's try another one of these. This one's slightly more difficult. I just want you to try foiling this. It's the same thing we've been doing, but have you try one before we move on to something else.
So we're doing this until like 3:30, right?
At 325. So hopefully you can give me 4 more good minutes here.
Okay, so we have 8x squared plus 6x plus 1.
Very good. All right. Now, the original problem actually had a 3 on the outside, which means we're going to multiply each of these inside by 3. 24x squared plus 18x plus 3, and that gives you the correct final answer. All right, so let's try something else here related. Let's say I ask you to multiply x squared times x to the fourth power. Do you remember what you do to the exponents when the bases are the same? You add the exponents.
Uh,
What would this become?
you. So you just add like x plus 2 and x plus 1. I mean, x
You're
plus 1.
adding, what are the exponents in this problem?
X or 2. Thinking about 2 and 4.
The exponent, the superscript number, the number, what are the only numbers that you see?
Oh, 2 and 4.
Okay, those are the exponents. This becomes x to the sixth. Feels like you've never seen that before. Is that true?
Yeah, I don't think I've done that yet.
Okay, this was covered in your class last year. Now, whether you remember it or not, I mean that's a different story. But I'm not trying to give you new stuff, but this should look somewhat familiar. So try this one here. What is x to the fifth times x cubed?
So okay, so we have then it equals x plus 5 plus 3, then it equals x to the power of 8.
Very good. All right, so let's say there's some numbers in front, like 2x cubed times 4x to the ninth. Guess what you do with the numbers?
Do you divide them? Do you want to get rid of
Multiply.
them or keep
You
them?
multiply. Multiply.
Uh,
And then what would the exponent be above the x here based on the 3 and the 9?
oh, that would be 12.
There we go. So let's have you try one here. Let's say it's a 6x times 3x squared. What is the exponent above x when it's not written?
0.
Nope. X to the 0 is 1, which means it goes away. It's a 1.
So it is 1.
All right, so what does this become?
Okay, so it becomes a 9x to the
How did you
power of
get 9?
3.
How did you get 9?
I added I mean, oh, that's right. Sorry. I was adding them, not.
Okay, let's
18.
multiply them.
18x to the power of 3.
Good. All right, we're all done for today. So we're going to stop right here.